Morning students, welcome to the world of physics. I am here to discuss today about the chapter of gravitation which is in class 9. Now before we start any topic, we must know what we have done in the past. Before that, we have undergone two chapters. The first chapter was motion and the other one was force and laws of motion. See, we always say physics is a study of natural phenomena, and we study what we visualize actually in the world. So in the first chapter, you were told about motion, and we have come across many physical quantities like speed, velocity, acceleration, and then we have three equations of motions which were governed by a body which is moving with a uniform speed. Then in the second chapter we talked about force, and then after knowing what is the concept of force, we were able to talk about three laws of motions which are the under principle of the motion of a body, and they were given by Isaac Newton, and they are known as laws of motion. In the first law, we know that every body continues to be in state of rest or uniform motion in a straight line until or unless it is compelled to change that state by an external force impressed on that body. So for first law, we normally say the mathematical can be the F net is 0, or it gives us a qualitative definition of force. For second law, you were taught that force quantitatively is equals to the product of mass and acceleration. And for third law, you know it is the law of action and reaction. So to every action there is always equal and opposite reaction. So with this background, today we will be coming up with a new chapter called gravitation as per the NCERT syllabus. And in this class, we will be talking about a very important law, universal law of gravitation. And in that part, we will be talking about the statement of the law. Then we will be having a formula or the mathematical expression for the same law. We will be talking of some basic fundamental units. And then, obviously, we will be talking about the importance of this law. And based on the formula that we will be establishing, we will be doing simple numerical problems based on that universal law of gravitation. Now, to introduce the chapter of gravitation, we will again come back and we will be talking about the word force. And in this chapter, I have already discussed that what is force. We always say in simple language it is a push or a pull. Now, in that chapter, we were talking about I am applying a force on a body, and due to that application of force, the body is moving, or I can make that body to rest. Now, take one more example of the similar phenomena. Suppose this is a marker in my hand, and what I am doing is, I am just dropping it. Now it is coming down. I have not applied any force to that marker, and it has fallen. What had happened actually? This is the Earth's surface. So what is happening is, the marker gets attracted towards the Earth. It means, without any contact, the force is acting. And this force, which is a non-contact force, is nothing but it is gravitation. So, whenever we have two masses in fact, so this was a simple example in which I was talking of this marker and Earth. Now, whenever we have two bodies, say this duster and this pen, so they are two masses, say M1, M2, they will have some force of attraction which is always there. So that is called gravitation, and the beauty of this law is that it is applicable not only to these two bodies which are in my hand, this law is applicable to all the bodies which are there in the universe. So that is why we have written universal law of gravitation. Universal means it is not only valid for the bodies on Earth. Body on Earth means terrestrial body. it is also valid for celestial bodies. Celestial bodies means the bodies which are not on the surface of the earth. Clear? So that is the broadness of this law, that it is a universal law of gravitation. And sometimes people also say that it is the fourth law of motion, or it is the fourth law given by Newton. Now, in many books you might have read that millions saw an apple falling, but Newton said, why? See, this statement is there everywhere, everybody of us are aware of this statement. But it was not exactly that it was only contributed by Newton. But Newton was a great mathematician and a great physicist of his own time. And he gave this law of universal gravitation, which is sometimes known as Newton's law of universal gravitation. Clear? So we will be talking about these points later on. So this law was given by Sir Isaac Newton, and see, we are talking of very early part. It was somewhere around 1687 to be precise. So means I am talking of the 17th century. Before that, there were various scientists like Copernicus, Galileo, and most importantly, Kepler. They also contributed to the study of gravitation. But Isaac Newton in this year came up with a very bold statement that whenever there are two bodies in the universe, they will always have a force of attraction, and that force of attraction, say F, will be always proportional to the masses of these two bodies. If suppose one body is m1, the other body is m2, their size and shape will vary. Just for it is a coincidence that I have made them a sphere. So they are two different bodies of mass m1 and m2, and if this is the distance between their centers, so normally to keep the notation in the standard form, we have represented the distance by r. So what Newton said, that there will be a force of attraction between these two bodies, and that force of attraction will be always proportional. See students, this is a sign of proportionality. So this is always proportional to m1, the first mass, and it is always proportional to the second mass, m2, and the third thing which is very important is it is inversely proportional to the square of the distance between them. 1 upon r square. So that is to be kept in mind. And see, this is m1, m2, it means it is proportional to the mass, the force of attraction. It means the mass will increase, naturally F will increase. And the most important thing is 1 upon r square. Inversely means if r will increase, naturally F will decrease, and vice versa. So if I want to eliminate this sign of proportionality, then clubbing it, firstly I will write m1 m2 upon r square. This is simple mathematics, everybody knows. Now if I remove this sign of proportionality and I introduce the sign of equality, so I must put a constant here, and that constant is denoted by a capital G. So this becomes F. So this is the mathematical formulation. Again I am emphasizing that the force of attraction between any two bodies in the universe is always proportional to their individual masses, and it is inversely proportional to the square of the distance between them. Clear? So with the increasing mass, the force of attraction will increase. With the decreasing distance, see r is in denominator and it is in square. So if r will decrease, naturally F will increase, and vice versa. So this is a very simple law which was given by Isaac Newton. Clear? Now if we want to find the value of this constant, this is interesting. This G is called universal gravitation constant. Clear? And this G does not depend on the masses and the distance. Clear? So if I want to see what G is, what I can do is, I can take this G out from this formula. That much of mathematics you must be knowing it. If I separate out G, it can be written as F R square upon M1 M2. So what I want to do is, I want to find what is the unit of this G. It is in your course. So the unit of force is Newton. This is R, which is distance, square of distance. So this becomes meter square upon mass. As per the SI system, the mass must be in kgs. So we have two masses, kg multiplied by kg. So it becomes square of this kg. So these are the units of G. And since it is a constant, it has got a fixed value. So the value of G experimentally determined is 6.67 into 10 to the power minus 11 Newton meter square upon kg square. So this value is very less. See, and it was determined later on, not by Newton, by a well-known scientist called Henry Cavendish. He performed an experiment in which he was able to find this value. So this value is very small. What does it mean? It means the value of this force naturally will be large if the value of masses are large. Clear? So it means if I am standing here on the earth, it is due by virtue of the gravity that I am standing here. And you see, the rivers are flowing. It is all due to gravity. We have rain falling, which is again the effect of gravity or gravitation. So this is the underlying formula for gravitation, and with this formula we can do a simple numerical based on this formula, in which you will be given certain values and you will find the unknown thing. Now I am writing a numerical. You please try to do that problem. It is only formula based. So the problem is, you have to find or find the force of attraction between a body of mass, say the mass is 1000 grams. Find the force of attraction between a body of mass 1000 grams placed on the surface of Earth. Clear? Now what is given? You have been given that mass of Earth, which is enormous, is 6 into 10 to the power 24 kgs, and the other value is radius of Earth. The radius of Earth has a value of 6.4 into 10 to the power 6 meters. Sometimes it is given in kilometers, so it is 6.4 into 10 to the power 3 kilometers. So we have to change the units accordingly. Now, just go through the problem, and whenever we do any numerical problem, the key is that we must spend up firstly what are the things which are given in the problem. So what is given? You have to read the question maybe once or twice. What is given? Mass. So I can draw a rough picture. Suppose this is my Earth, and this is some mass which is there. Clear? And obviously this is the center of the Earth, and the radius of the Earth is given. If I denote it by say R. Clear? So what is the value of this M? We will do it. M is given as 1000 grams. See, the SI system demands that the mass must be in kgs. Good. So 1000 grams means it is nothing but it is 1 kg. Now this mass of the earth, suppose I denote it by capital M with a small e. So this e represents that the mass of the earth. So what is given? This Me is given as 6 into 10 to the power 24 kgs. See, which is just compare the value. There is a huge difference between the masses. Fine. And r is given. So this is the distance, obviously. This is also r. We are assuming that earth is circular in shape. So RE, this is the standard notation, radius of earth. This is given. Now, simply what we have to do is, we have to use the formula to find the value of F. Clear? So the mass is very small. So this is its center and this is the center of the earth. So we will have force something like this. F here also. F is the vector quantity, which we have already talked about in the previous chapter. So F can be written as G. So instead of M1, I will have a M of M2. We will have ME, and the square of the distance between them becomes RE square. Now simply that much mathematics I must know. We will put the value of G. This is small m is 1 kg. Capital M is 6 into 10 to the power 24 divided by square of radius 6.4 into 10 to the power 6 whole square. Now it becomes a purely a mathematical exercise for you. So you must know you have to square it. So it becomes 6 square. So it becomes 10 to the power 12. This is 20 to the power 24. So you can make a rough estimate. In fact, it can be written as 6.67 into 10 to the power minus 11. And if I square it, I will have 6.4 into 6.4. Clear? This is 10 to the power 12. And this 1 becomes 1 into 6 becomes 6. It becomes 24. So what I want to do here is that I want to have a rough idea. What is the value of, what is the magnitude of this force which is there between a body of mass 1 kg kept on the surface of the earth. Clear? So this becomes 12 and this is positive 12 minus 11. So it becomes 10. So roughly if you see this, these are all 6. So they will not give anything, some quantity equal to 1. 1 6, 2 6 numerator, similarly 2 6 in the denominator. So if you calculate, approximately you will get a value of 9.8 volts Newton. So you see, this value is 9.8 Newton. This is the force. Now you can see, you can always ask that this is very small and the mass of earth is very big. Clear? So what actually happens is that due to the large mass of earth, clear? So this body will experience an acceleration. You can always ask why the earth is not being attracted towards that body of mass 1 kg. So the answer can be in terms of Newton's third law. So the force is, the magnitude of force is same. But what is the underlying point to be understood here? It is that as per the second law, we simply know F is equals to ma. Now A can be written as F by m. So what does it mean? It means the acceleration is proportional to, is inversely proportional to the mass. Since this body of mass 1 kg, the mass is very less. So the mass is very less, so its acceleration is very large. Now if you compare it, if you put the mass of earth here, naturally m is very large, 20 to the power 24. So A will be very less. So the example in the beginning, what I was giving was that this pen, its mass is very less, so its acceleration is large. So it is experiencing a force of gravity attracting towards the earth, but since the value of mass of the earth is enormous, so we hardly see, we hardly experience, or we cannot measure that earth is being attracted actually by the small body whose mass is of the order of few kgs. This is one problem which is a very standard problem and which can give you an idea about the magnitude of the force, and you can see the value of F becomes very large if this M becomes large. Suppose I talk of Earth and Sun, I talk of Earth and Moon. The mass of the Moon is of the order of 10 to the power 22. So if here I have a quantity equals to 10 to the power 22, naturally this F will be very large. Clear? So on the basis of gravitation, we can explain so many phenomena like the motion of Earth around the Sun, the motion of Moon around the Earth. We have the formation of tides, high tides, low tides. What happens is there is a force of gravity between the Moon and the sea water. So which is making these tides. In Hindi we call it as Jwar Bhata. Clear? So this is one of the simple examples. And whenever we have a concept of satellite, so all the satellites, they are revolving around, say, if there is a satellite around the Earth, which is orbiting. So whatever data we are getting, and these days we always talk of GPS, Global Positioning System. So it is all due to this law of gravity. And we can do other problems also based on this formula. And the main point is to be that F is proportional to 1 by R square. So this is sometimes called inverse square law. So if R becomes more, if the separation is large, if I make instead of R, I make it 2R. Naturally, the value of F becomes 4 times less. So if I bring the masses closer, the value of R will reduce. Naturally, F will increase. So we can do, in the next class, we can do various problems based on this inverse square law. That's all for this class. So see you in the next class. Thanks for joining.
PIT Global School, an English medium school surrounded by lush green environment, warm, eco-friendly and secured atmosphere, colorful and spacious AC classrooms with comfortable furniture, indoor games and sports club facilities, smart classrooms, best environment for music, singing and dance. Come today and feel the difference.
Admission open for pre-nursery to class 9. BIT Global School, a CBSE affiliated co-educational secondary school, Partapur Bypass near Subharti, Meerut.